Hi everyone, this is EasyElimu channel. I'm Vincent Kalumaya and I'll be your teacher for today. I'm going to guide you through Form 3 mathematics and we shall be learning further logarithm. Stay tuned as I welcome you all. We know from basics of mathematics, we know that you may be given a number like c equals to a raised to b. In this case, we say the number is written in index notation. Now, this number can also be written in logarithm notation, and you may find that given this kind of number in logarithm notation, this one first we have said is index notation, whereby now it is to base of m, but the power is b. This is what we refer to the power. Now this is the answer of that given value. So in logarithmic notation, what we are going to do is this. We shall introduce the log, then it is to the base of what we have as the base there, then it is the power here becomes our answer, but it will be log to the base of that number, which is c equals to b, and this one will be interpreted or read as log of c to the base of a equals to b, and is interpreted by the logarithm at which, or the number to which, the logarithm to base of a must be raised so as to get c. So b is the power to which a must be raised to find c. So the logarithm of c to base of a is equal to b. So we shall see an example here, and I'm going to give an example of real life situations which we deal with, and that is in mathematics. And we shall find one of them is 25. Actually, let's deal with this 5 squared equals to 25. And from this we can view that here we are having 5 as our base, and square meaning that we are taking 5 multiplied by 5, which is 5 squared, and we shall get 25. This number can also be written in logarithmic notation, and you will find out that this one is in index notation. If written in logarithmic notation, you will find out you are going to have log of 25. We take what we have as the answer, then whatever is as the base remains the base of our logarithm, and then what we have as the power becomes the answer of our logarithms. For this case here, our power was 2, so that 2 becomes our answer for the logarithm. And this is the power to which 25 must be raised, the power to which 5 must be raised in order to give 25. So if you want to reinterpret this logarithm, you will say it is the logarithm to the base of 5, or the 5 is logarithm to which 5 must be raised to power 2 in order to give 25. So that is how you will find it. So it is the logarithm to which 25 must be raised to find 2. That is the base of 5. So that one we can find that. But you know, using this method, you cannot use it in calculators or in logarithm tables. Since logarithm tables and calculators give answers to the logarithm to base of 10. So if it were this 25, you could find another thing else. But here we find that in log tables, or we call it mathematical tables, where you will find there is logarithms of numbers, you will find out that it will be giving you an answer to the base of 10, and also calculators gives answers to base of 10. But here is to base of 5. I will show you later as we move on how you can convert a given logarithmic notation number to base which is not 10 and make it to base 10, so as you work out using a calculator as we move on. Note that from index notation we said any number raised to 0 is equal to 1. And any number, if you have a here, for example, then you raise to 1, you will still get that number. If you have a number, you raise any kind of number, you raise to 1, you will get that given number. Be it 5 raised to 1, you will find 5. If it is 100, you will find, if you raise to 1, you will find 100. And if it is 100 raised to 0, you will find 1. Even if it is 25 raised to 0, you will still find out 1. If you write this one in logarithmic notation, you will find out that you are going to give out the log of 1 to the base of a is equal to 0. Meaning that the logarithm of 1 to any number, to the base of any number, is always equal to 0. I say the logarithm of 1 to given any number as the base is always equal to 0. And here we can write this one as log of a to the base of a is equal to 1. So meaning that the logarithm of any number to the same number is always equal to 1. With that, we can solve some of the logarithm using calculator and math tables. And using mathematical tables, I remember we worked it in Form 2, so I do recall that you know the knowledge of how to solve using mathematical table. So today I shall introduce you on how to solve logarithmic equations or solution using calculators. And for example, we shall start with we know calculators give answers to the log of base of 10, most of them. So what we shall do here, I'm going to write the base of 10 and we find the logarithm of 5. We also find the logarithm of 10 to the base of 10 of 100 actually, and see what we can find as we move on. So let's start with that. What we are going to do here, you will take your calculator. If it's, for example, what I'm using, that is FX82MS, that is Casio company, you will find out most calculators in the secondary schools are using this. So if you are using the same calculator, you do go to the main bars here, which are in black but written in white. It may be another color. You press log key. So you press log key, or you key in log key. Key in log, as I have done. It will display log on the screen, and that is log to the base of 10, but it is only log. So if it is 5, then key in 5. If it is 5, you key in 5. After keying the number, you then key in equal sign. And you will find the screen display a very long answer, which is 0.6989700004. So you will put it to 4 significant figures or 4 decimal places, and you will find you have 0.69 and 904, 4 decimal places or 4 significant figures. That is what we are going to find as the log of 5. And if it is 100, the same applies. Key in log. After key in log, then key in 100. You will find the screen displays log 100. Screen displays. You will find a display of log 100 on the screen. So after displaying that, key in equal sign, and you will find your screen will give out your answers 2. The screen displays 2 as the answer of log of 100. So we can see, if you have been given to calculate a log to the base of 10 using a calculator, that is how you do. You just key in log using a calculator made from Casio company, if it is resembling this of FX82MS. Then after keying log, you key in the number which you want and then equal sign, and you will find the log of that one. If it is too long, then you will be required to round off to the given number of decimal places, and you give out the answer as required. So I will give you an exercise concerning that. As you have seen, I want you to find the log of 20. Find the log of 20. Also give me the log of 4. All of these are to base 10. I want you to find the log of them, and I will help you to find the log of 12. And to just remind you how to find it using a calculator. This one you can still find them using mathematical table. All of them will be the same. So if you are using calculator, you will key in, for example, if it is 12 for this case here, I'm keying in log, then you key in that 12. The 12 meaning you key in first 1 and then 2. You will find your screen displays log 12. After this display, then key in, this is step 3, key in equal sign. You will find an answer is displayed at the bottom of the screen as 1.0791811246. What you do, you cut it to the required number of decimal places. For me, I do like cutting it to 4 decimal places, I mean. So if it is 4, you will find 1.0792 to 4 decimal places, because this one it will be rounded off to the nearest tenth, and I will find the next one will be 2. So it is 1.0792. Using the same procedure, use a calculator to find log of 20 and log of 4. Using the same technique, find the log of 20 and 4 using mathematical table and compare the two answers and see what happens. So with that, let's see how we can express also the logarithm we have said in expression of logarithm notation. In case you have been issued with log of, let's say log of 125 to base of 5 equals to 3. And you have been told, express that one in index notation. You may be required to express in index notation. What you do here, in expressing to index notation, you now take this way. You will take this 5 will remain your base, this 5 base. Then 3 becomes your power. This is the power to which it must be raised. So you will take this, you raise that one, and then it will give you this one here. So that is equal sign. You are going to get 5 raised to 3. You will be equal to 125. That is how we do write in index notation. And in case, even if you have been provided with a number, let's say like 8 raised to 4 is equal to 4096. 4096, for example, if that is the number. The same applies if you want to write a number from index notation to logarithmic notation. What you are just required to do here, you write the log, and then here, this is what we refer to our base. This becomes our base to which that log must be found. Then this one will be the answer, but this is the power to which that number must be raised to bring this number here, but will be the answer in logarithm notation. So this one is the number which that base must, the logarithm of this number to base of 8, it will give you that one. So this one becomes here, so you will take it here and becomes 4096. But base remains our base here, and you will find the power will be our now answer to which, when you find the logarithm of 4096 to base of 8, it will give you 4. Using the same technique, find, let me give you one. Write in logarithmic notation. Write in logarithmic notation 3 cubed equals to 27. Use the same technique to write out in logarithmic notation. And remember, this is what we are just doing here is an extent of what we did in Form 2 and a logarithm. So this is further logarithm, we are just expanding on what we learned in Form 2. So using that, write in logarithmic notation, and you can write many of them which are given in index notation, and write. You can find many of the numbers which are written in index notation and write them back into logarithmic notation. With that, we have come to an end of the introduction in further logarithm, and we are going to the first subtopic, which we shall be looking at laws of logarithm. That are further laws of logarithm. From Form 2, we learned that from laws of logarithm, we had a raised to m multiplied by a raised to n. We said this is the same as taking a, and then we sum up the power, if you remember very well. And if it is a raised to m divided by a raised to n, we say it's the same as taking a, m, subtract, and then you find the difference in the power. If you had a raised to n, m, then you raised to another n, it was the same as a, then the power you could multiply, and this one could gave us mn. Now we want to use this kind of notation here to find further laws of logarithm using the same notations, and we shall start with the first one there. We shall start with a raised to m multiplied by a raised to n equals to a raised to m plus n. Now from that one, we shall say this. Let's take that our am there is equal to x. Let a raised to m equal to x, and a raised to n equals to y. Since we have formed two logarithmic, we have formed two index notation, we can write them back to logarithmic notation and say that if we needed to find that one, it will be that logarithm of, we said it will be of this x, which is the answer, to the base of a is equal to m, and here we shall have the logarithm of y to the base of a equals to n. But here we can say that since we have said a raised to m times a raised to n is equal to a m plus n into bracket, and we have found am here is equal to x and an is y, we can say that if you take a raised to m multiplied by a raised to n is the same as taking x multiplied by y, which is xy, because am is equal to x, as we said, let it be, and an is equal to y. So we shall find it at that point, that case. So this one here is the same as taking am plus n. It still gives us the same answer there. So that is what we are going to find. And then we can say further that if we introduce the logarithm there, we are going to have that the logarithm, from this one, we can say that whatever we shall be having, let's consider this part here. And if we consider that part, we can say that if we find the logarithm actually of xy to the base of n, we are going to get m plus n. Remember how we have worked out, and we have found that if we find the logarithm of xy to the base of a is the same as that, since am multiplied by an is the same as xy, which is that one, from what we have observed. So doing that, we will be finding that. So, but remember here we said, if we are finding that one, then this m here, we said let it be equal to log of a, the base of a of x. So this m will be equal to log the base of a of x, and we add to the log of the base of n of y, and we will have found that kind of identity. It has formed something new, which is nice, and we do call this one as further logarithm of that a_m multiplied by a_n equals to a_m plus n. So we have found that if you have two identities or letters which are, you want to find the logarithm of those two numbers, it's like taking the log of one of them to the same power and the same base, then you add to the log of the second of them with the same base. So we have seen how it comes about. So let's see, in case of a division, what will we have? We have seen, in case of multiplication, if log of base of a is xy, then of xy is equal to m plus n, is the same as that one which we have there. Let's see in case of division. In case of division, whereby we have am divided by an equals to am minus n, then we shall say this. From there, we shall form some of the equations, and we shall say, let am be equal to x still, and an be equal to y, such that log of x to the base of a will give you m, and log of y to the base of a will give you n. From this one, I'm referring from that statement which we have laid there. So with that, we can come to our equation here up here and say that if you take am divided by an, it's like we are just taking, because it's am, so am is x, so it's like taking x, and an is y, so we take divided by y, and this one will give you a into m minus n. That is what we find there. From here, we can say that we shall take this right hand side and say that if we find the log of x over y, log of x over y to the base of a, from what I showed you, is equal to m minus n, because this one is in index notation, and writing them into logarithm notation, we shall write the number which is on the left hand side as constant there, so it will be the number which we need to find the logarithm to the base of a will give us the power, so we have that one. So we have found that one, and this one here is still the same as what we have behind. So we can say that if we have that one, we can replace and say that we have found that the log to the base of a of x over y is equal to m minus n. But remember, m here, we have said that such that m is equal to log of x to the base of a. So it will be log of x to the base of a minus shall remain, n is log of y to the base of a. So we are finding out that if you are having am divided by an, which is a raised m minus n, then we are finding that if you let am be like x and an let it to y, you will finding out you are going to get that in case they are represented by xy, or you have two numbers, you are like dividing them and finding the log to the same base. It's like taking those two numbers which you have to find the quotient with the same base, you subtract them and you will get the answer. So we have seen with what we have worked out, we have found out that is how we can do that out. Now let's see another one that third process. Let's see the third process, whereby we have been given a, m, n. Here, what we shall do, for here we have told this one, if you have that one, is the same as a, m, n. But we shall consider another method, whereby we shall be using the logarithm of a certain number raised to something. So let's say we have logarithm of ax raised to n. Let it be equal to something like y. If we take that is the case, then we have to write it in index notation. And if we write in index notation, we are going to have that this one will be raised to that power. And if it is raised to that power, we are going to have ay is equal to what we had here, which is xn. That's what I'm going to find. Then we can find the nth root on both sides. You find the nth root on both sides, and you will find that this nth root will simplify, and you will find the right hand side will have x, and left hand side will have this. Finding nth root here is the same as dividing the power by that nth root. So it's the same as writing y over n. That is the nth root. This one means the power to which you must square, and this is the power to which you must find the root. So this one is the root, and that is the square power. So we are going to find is the start same. So it's a y over n. After getting that, we can write it back to logarithmic notation and say that this number will give us x. So it will be log to the base of a, because that is our base, of x, what we have, is equal to y over n. But we can simplify further by multiplying both sides by n, such that we have n log of the base of a of x is equal to y. So we have found that in case you have been given any number in form of log base a x raised to n equals to y, that number is the same as finding the log, or just say this number here is the same as finding n. You take n, you multiply that log to the base of a, then it will give you whatever you are looking for. So that is what we have concluded from that situation. So we have seen the three further logarithm equations which have arrived from the normal equation which we knew from Form 2. So we shall be using them as we go on with our calculations in further logarithms, and we shall see how it will affect our workings. For instance, let's see an example whereby we are told, given that log of 2 equals to 0.3, log 2 equals to 0.3010, and log of 3 equals to 0.4771, log 3 equals to 0.4771. All these ones are given to the power of 10. Then they have told you, given those, find log 3, find log 3 times 2, written as log 3 times 2. So we needed to find that one. From what we have learned, we have seen that if you have log to the base of a, of which this is log the base of 10, of xy, or just say xy, of xy is the same as taking log to the base of a of x, then we add log to the base of a of y. That is what we have seen from what we have found earlier. So with that we can say, if this is the case, then for our equation here, or our expression here, we can say that this one is the same as writing log to the base of 10 of 3 plus log to the base of 10 of 2. So instead of even writing log to the base of 10, we just know if we write that one, we are meaning that it's log to the base of 10. So we have simplified this further to that one. And we know we have been given log to the base of 3, we have been given is 0.4771. Then we shall add to that of 2 is 0.3010. Now we are going to get, the total will give us something. We shall find out that if you do the logarithm of this one, you are going to get 0.7781. So this is the logarithm of 3 times 2. If you do logarithm of 6, you will get, it will give you whatever we have found there. And that is the answer for that question. Then we have another one which includes division. And that is log 3. Actually, it's log 1.5. We have been told to find log 1.5, but remember here, we were only given log 2 and log 3. We haven't been told to use calculator or to use mathematical table, but we were told logarithm of 2 is equal to 0.31010 and logarithm of 3 is equal to 0.4771, and now we are being given logarithm of 1.5. These people are testing us. What they are testing is your skill to know how to compute mathematical symbols. For example, simple calculation in mathematics include this one. We know this one, in order to get this one, if you make it as a fraction, you will find it's 1 and 1 over 2. And if it is improper fraction, we are going to get this one here will give you the same as 3 over 2. So that 3 over 2 is the same as what we are having here. We are having 3 and we are having 2. So we can use that one. And remember, this 3 over 2 is just still a division. So meaning, we can find the logarithm of 3 over 2. And it is to base of 10. So if having that, remember what we said? We said that if you are having log of x over y to base of a is the same as taking log to the base of a of x minus log to the base of a of y. So in this case, we are having log of 3 over 2. So we shall say that one is the same as log of 3 to the base of 10 minus log to the base of 10 of 2. So that one is going to give us log 3 we are having is 0.4771. That is 0.4771. And log 2 we are having 0.3010. So if we compute the 2, we are going to see that we are arriving to an answer of 0.1761. 0.1761. That is what we are finding as the answer of that. So meaning that if you compute the log of 1.5, you will find 0.1761. Let's consider another one which is now a multiple, and it is log of 54. As you can see here, we don't have 54. Here, we have been told to find the log of 54. But what they have given us is log of 3 and log of 2. So what we are going to do here, we shall now reconsider in what multiples does this involve. And we shall find this one is the same as finding the log of 27 multiplied by 2. And 27 by 2 you will get 54. But this 27 here can still be made into multiples. So it will be log to 3 squared, 3 cubed actually, because 3 squared is 9, 9 by 3 you will get 27, so that is 3 cubed multiplied by 2. But remember we said, if you are having a log, for example, the base of a of x raised to n is the same as writing n log to that base of x. So that is what we are going to have, and this one here shall be simplified further. or just let write as it is. Now this one here, we shall rewrite that one and say it is equivalent to, from the rule, we know that if you have this one, is the same as writing plus log of 2. So if that is the case, then this one we shall use that third rule which we find, and it will be 3 log of 3 plus log of 2. And we shall find log of 3 we have been given is 0.4771, and log of 2 we were given 0.3010. So if we add the 2, we are going to multiply this one and then we add together and see what we shall find as the log of 54. And we are getting the answer there is 1.7323. 1.7323. That is the answer for that log of 54, and that is what I'm finding there as the log of 54. So we have seen the answer becomes that. And at a case, you may be given some of the numerical figures, and at the same time, you may encounter some of maybe just letters, and you'll be told to simplify further using the same process. So we may involve another one which touches the third rule, which we have seen under laws of logarithm, further laws of logarithm, and we can say you may be told to simplify log of x raised to 4, let's say plus log of x raised to, actually let it just be x. If you are told to simplify this one, whatever we shall do here, we are going to make this one to the third rule, and we shall have log 4 log of x plus log of x. And if you have a problem in just adding directly, you can say let log of x be equal to a, such that you will have 4a plus a, and this one will give you 5a. And if it is 5a, then you can replace here and say, we say let log x be equal to that, so it will be 5. A is log x, so you will have log x. If you may find a difficulty in just adding directly there, so you will find out you are going to have that, and that is a simplified form of log x raised to 4 plus log x. So we have seen a simplified form is that. Let's see how we can find that logarithmic equations and expression. And we can involve some of the equations here, like log maybe to the base of 3 of 81 equals to x. So we are required to solve for x. Now we need to solve for x. Here remember one thing. We said if you have been given a numerical figure or a certain something like this, it may be represented, either mathematical equation may be represented, which it may be in this form, may be represented either in logarithmic notation or index notation. So this one we can still represent it in logarithmic notation and find out what is the value of x. So in index notation, we shall have this one will be raised to that, and we shall find it is equal to this. So it will be 3x is equal to 3 raised to x is equals to 81. And if you need to make the same base, you will find that 3 raised to x is equal to, if you make that one with the base 3, you will find, you are going to find 9 by 9 is 81, so it will be power 4. So you are going to get, if the base are the same, remember from form to work, if the base are the same, then it means also the powers are the same. So meaning our x here is equal to 4. That is how we just simply solve that one, and we can say this one is equal to 4. So x is equal to 4. The same can be given as we need to solve for we have been issued with another logarithmic equation, that is log 8 the base of x is equal to log 8 the base of x equals to 3. Now we need to find out what is the value of x, to which base is 8 found by logarithm to get 3. To which base will you find log of 8 to get 3? To find that, we shall do the same, and we are going to get x cubed is equal to 8. So it will be x cubed is equal to 8. Here we can make it to simplest form of its power or its multiple, and if we make that, we shall find that x cubed is equal to 4 by 2, which is equal to 2 by 2 by 2, which will give you 2 cubed. And if that is the case, you are going to get x cubed is equal to 2 cubed. Since the powers are the same here, then we have no doubt to find that x here are also equal to 2. So our x is equal to 2. In that, if you take x cubed, you should get 2 cubed. So that means whatever is missing is x is equal to 2. So we have found that x there is equal to 2. Let's see another example. We have been told solve for x where log x plus log 5 equals to log 30. Solve for x where log x plus log 5 equals to log 30. In this equation here, we shall recall whatever we done with the further logarithm formula, which we just seek short while ago. So what we are going to do here, you will introduce whatever we have. We remember that if you have log xy to the base of a, we said it will be log to the base of that a of x plus log of y to the base of that a. But here we are being issued with this. So meaning that if we seek the log the base of a, which is log 10 for our case here, then that one will be, if we multiply by 5, x multiplied by 5, then it should give us log to the base of 3 of 10 of that. Now here, after reaching this point, you will drop out, because log is the same base, you drop out the logs, and then you will have x 5. You will have 5x here is equal to 30. If you work out, you will find that you are going to have x as 6. You drop the logs if they are only on the same base. So after dropping the logs, you will find out that if you work out, you are going to find the missing value there is 6. Such that if we place here 6, you will find the log of 6 plus log of 5, we are going to get is 30. Now we shall see another example here. We shall see another example. But here I see we can work it in another way, and we'll still give you a accurate answer. In that you may decide, okay, I'll give you a hint, but that one you are going to work it. Here you are going to take log of x. Now you subtract log of 5 on both sides. That way, such that this one will cancel out, and you remain with the log of x is equal to log of. Now, because it's division, it's subtraction, then it means it is division. We can do divide there, and if we divide, you are going to get that we are going to divide the numbers or items which are under log finding. So we shall find out, we have, if to the base of 10, this one is going to give us log to the base of 10, or what we just have there of 6 is equal to log of x. So as you can see here, log of x is equal to log of 6. So x here, it will be equal to 6. So you can see that one gives us clearly than just ignoring the logs. So I'll see if I will find one example I give you work out. See that one I have worked. Let's tackle another one. We may have x plus log x. Solve for x. If 2 actually is 2 plus log to the base of 2 of 3 plus log to the base of 2 of y is equal to log to the base of 2 of 5 plus 1. So here what you need to do, you need to make everything or every possible term there to be the same. It have to be in the same condition. In that this 1, 2 here, we need to introduce log so that it may appear in log or to the base of 2. And if that one is the case, we shall ask ourselves, what is it that when we find to the base of 10, let's say that number is x, we shall find this answer which we have there as 2. And that one will give us that if that number we want to find, it will be 2 squared is equal to x in index notation. And you will find out that your x is 4. So here, instead of writing log to the base of 2, we can now replace that one and write, instead of 2, we put log to the base of 2 of 4. And the same should apply here. We say, what number, if we make it to the base of 2, we shall find 1. And we shall find that if you take 2 raised to 1, you are going to get x. So meaning x equals to 2. So instead of writing there 1, you can still write log to the base of 2 of 2. And we will find the same given answer. So now we can do our sum. And remember we said, if you are having log xy is the same as log to the base of that a of x plus log to the base of a of y. And now this one, all of them are addition. So meaning they lie here, but here is like we add z, and here we add log to the base of a of z. It's just the same because there are 3 there. So with that information, we can work out and find what is the value of y. Since we can say, instead of writing this, we can just write log to the base of 2 of 4 multiplied by 3 by y is equal to log to the base of 2 of 5 multiplied by 2. And this one is going to give us, if you take 4 by 3 by 2, you are going to get 12y. So it is log to the base of 2 of 12y is equal to log base of 2 of 10. Now because we have log base of 2 in both cases, so we shall just drop the logs and we have 12y is equal to 10. Then we divide both sides by 12 and we shall find our y here will be equal to 5, 2 here, 6. So y is equal to 5 over 6. You find that y is equal to 5 over 6. That is how we do solve logarithmic equation and expression if given using further logarithm method. Next we are going to see one of the equations you may find an expression. Let's now see how we can solve logarithmic expression. All what we are dealing with was logarithmic equation. Now let's see an expression. An expression may include log 25 plus log 625 divided by log 5. Actually, this one we can factor out, and if we factor out the numerator part, we are going to get is log 25 multiplied by 625 over log 5. So that's what we are going to get. And here we can go on factoring inside and we shall find log. Now 5 here we shall find is 5 squared and we shall multiply by 625. That is, I think 5 squared, then 25 by So here we shall find, you will find that one if you simplify further out. And after simplification, you are going to find, if you put log out, we are going to have 5 squared multiplied by 5 raised to 4 over, this is 5 raised to 1. So if you simplify, this one will be 1, here will be 5 raised to 1. And that one is going to give you log of 5 raised to 1 to that one is just taking the power, you add the 2 powers. So you will get 5 raised to 5. And if that one is the case, then we are going to have log of 5 raised to 5. And that one can be written as 5 log 5 from the formula which we just recently sorted out. So meaning that we can simplify, this one is a logarithmic expression. We have simplified it to 5 log 5. You can use the same method, and I want you to work out one of the example here. I'll give you one as an exercise. You work out and evaluate yourself if you have taken it in. So I'll give you log 8. Yeah, let me give you log 8 plus log 32 over log 4. Simplify. This is a logarithmic. It's a logarithmic expression. I want you to simplify it further and give the most easiest, simpler form. So you can simplify and get as I got mine. Let's now see how we can find further computation using logarithms. And here is where I told you I will show you how to find logarithm of numbers which have no base of 10. For example, you may be given, find the log of, or let's say, of 8 to base of 3. If you want to find the logarithm of this number here, you cannot use a calculator, which is normally based to 10, and also you can't use a mathematical table because it is always given to base of 10. This one is to base of 3. In order to make it to base of 10 so as you use, you will say, let this your log be equal to either x, p, or whatever you decide. And then after doing that, you write it back into index notation. You remove it from logarithmic notation to index notation, whereby this one will be raised to x, so you will have 3 raised to x is equal to 8. Now from there you can now find the value of x, whereby now you can introduce logarithm to both sides with the base of 10, such that you will have logarithm to base of 10, you will say to base of 10 now, b of this 3x, 3 raised to x, and logarithm also to base of 10 of 8. So if you do that, introducing logarithm or to base of 10 on both sides, will have improved your logarithmic, this expression here, to become now a perfect one of base of 10. And this one you can now use a calculator or a mathematical table to find out. For this case, we know this one will now be x into log base of 10 of 3 is equal to log base of 10 of 8. Now from here, what we know is that you can now find the value of x by dividing both sides by log to the base of 10 of 3, log to base of 10 of 3. And you will find clearly that your x is equal to, now if you divide, this one will divide itself, and you will find that x is equal to, now you can use a calculator to evaluate out, and you are going to get 1.8927892661. So meaning to, let's just take it to 3 decimal places or to 4 decimal places. If it is to 4 decimal places, we are going to get our answer as that one. This one we shall round off to give us 8, and we shall have 1.8928 as the value of x. If you refill here the value of x, you are going to find you will get 8. In that, if you take 3 raised to 1.8928, you will find it is 8.000094. So which if you cut, you will find it is 8. So we have found the value of x. And this is now, if you find the logarithm of 8 to base of 3, then your answer is 1.8928. And that is how we evaluate logarithms of number which are not to base of 10. We first make them to be to base of 10, and then we use either mathematical table or a calculator to evaluate their logarithms. Now let's handle the same example in another approach, whereby we are now going to find the logarithm of 3 to base of 8. What will we find? Will we get? What we are going to do here is first we shall say let this one be equivalent. Let's now say y, in such that if we write it back into index notation, we are going to get 8 raised to y is equal to 3. If you want the value of y here, you have first to make it in such a way that you introduce logarithm to both cases of base 10, in that you will have logarithm to base 10 in both cases, and it is with that number we are finding. For this one now we know if you have log of x raised to n, we said is the same as just taking n log to the base of a of x. So in this case here, we are justified to take y log to the base of 10 of 8 is equal to log to base 10 of 3. So in that case, if we need the value of y here, we are required to divide both sides by log to the base of 10 of 8, and also the right hand side with the same log 8 to base of 10. So we shall find that our y here is going to be log 10 over 3 log 3 base 10 over log 8 base 10. And you are going to get your answer is going to be 0.528320833. It depends with what you have, and that is what calculator gives. But you can't write all that. You just truncate, or you round off. Like for me, I round off to 4 decimal places, and I will get my answer as this to 4 decimal places. So you will find whatever we want here, the logarithm of 3 to base 8, we are getting is 0.5283. Now I think you understand how to find the logarithm of numbers which they have base not equal to 10. You can now find any of them, and I will give you an exercise to test yourself. I will give you find the logarithm of this number log of 6 to base 5, and see what you will find. We have 2x plus 3 minus 4 equals to 0. And if you have an example like this, understand that we can't make it to base 2 because this 3 will interfere with that. So we need to take another approach in such a way that it will incorporate everything that we have in this process. With that, we are now here free to say, let one of it, for example, if it is 2 raised to x, let it be as p. If we let it to p, then we are just find that here, because it's 2 raised to x, 2 raised to 2x, then here shall be our p squared. We are substituting, and here we shall have plus 3 into p, so it will be into p minus 4 is equal to 0. And here we can see we have found p squared plus 3p minus 4 is equal to 0. We have formed a quadratic expression whereby we can find the value of p by either factorization method, or we can use other methods of solving quadratic equation. But here let's just use factorization. So we can find out that if we work out, we are going to have p squared plus 4p minus p minus 4 equals to 0, such that p into p plus 4 minus 1 into p plus 4 is equals to 0. So we shall find out that p minus 1 is equal to, not equal but into bracket, we are taking the outside in the bracket, so p minus 1 and then 1 which is common in the bracket, so we shall have p plus 4 and this one is equal to 0. So if you take that, you will take one of the bracket and equate to 0 such that p minus 1 will either be equal to 0 or p plus 4 will be equal to 0 such that p equals to 1 or p equals to negative 4. So after finding that, you may prove using your equation, in that you may prove here and put here 1. If you take 1 squared plus 3 multiplied by 1, that is 3. 3 plus 1, you will get 4. 4 minus 4, you will get 0. So this one is okay. Let's prove that one. You will get negative 4 squared. Actually here, negative 4 squared, you will get 16. 16 plus negative 4 here is going to give you 3 multiplied by negative 4 is 12. So 16 minus 12, you are getting 4. 4 minus 4 is 0. So we are getting two values of p. We are getting two values of p, and p may be negative or positive case. So what we shall do here, we shall substitute and say 2x is equal to, so we shall say let it be equal to 1 first. And if you want to solve this, now you see where logarithm comes in. You have to use logarithm and you will introduce log on both terms. So it will be log of 2 equals to log of 1, and you will find out that this is x log 2 equals to log 1. And you will find log 1 is equivalent to 0. Actually log 1 is 0 and log 2. So you shall divide both sides by log 2 by log 2. And you will find this one is going to give you 0 because this one is log of any number, any base, any log of 1 to any base, we said it will give you 0. So this one will give you 0. And this log 2 is 0.301, and if you divide 0 and that, you will get 0, so x is 0. And at the same time, you may use p as negative 4 such that 2 raised to x equals to negative 4. So if we do that, you are going to get log to the base of 10 of 2x is equals to negative 2. It will be log of negative 4. And if that is the case, then we are going to have x log to base of 10 of 2 is equal to log of negative 4. And actually, if you work out, you will not get here because this one, logarithm of a negative number will not give you. So we are remaining with our answer as x equals to 0, because if you divide here, you will find the x equals to, this number here is not there, so you will not find. So we are remaining with our value as x equals to 0, because as we can see, negative 4 will not work with the logarithm, so we can't find the logarithm of that. So whatever we shall say here is this x here is equal to 0, such that if you substitute 0 in that case, you will find this one will give you 0. So 2 by 0, you are going to get 2 raised to 0 is 1, and 2 raised to 0 here is 1. 1 by 3 you will get 3, and here 2 raised to 0 will be 1. So 1 plus 3 is 4, 4 minus 4 you are getting 0, so that's justified. So x equals to 0. We have seen how you can handle that. We can do another one. Here what we are going to do here, we are going to work out and find what is the value of x. And since it is a a question involving the two, we can make it first to look like a quadratic equation. Then from there we can evaluate using logarithm, such that we can say, let this, because if we work out we shall not find it directly, so we let log 10 base x be equal to, let's say, letter k, such that if we substitute here k, we shall have k squared is equal to 3 minus, now this one we can change it to, remember what we said, that if you are having this one, it's like writing 2 log x. I think you remember from that identity which we have done there, that law of logarithm. So it will be 2, but this one we have said let it be, it is to base 10, so let it be equal to k, so it will be k. Then from there we can see we have formed a quadratic expression, and we can use any method of quadratic equation to solve that quadratic expression, in that we may make them to be plus 2k minus 3 equals to 0, such that if we use factorization method, we are going to find out that we are going to have k squared plus 3k minus k minus 3 equals to 0. If we factor out k, we shall find for the first two terms will give us k plus 3 minus, now we are factoring the next one, it will be minus 1, so you will get k plus 3, and you are getting this one to be 0. If you take the outside factors and put them together, k minus 1, you will find k minus 1, and you take one of the factor in the bracket, you will get k plus 3, such that that one is equal to 0. And if you expand that, these two quadratic expression here, you will find they will give you back your squares, or this quadratic equation. From these factors or square, you will find it will give you back whatever you add. So this one can be k minus 1 equals to 0, such that k equals to 1, or k plus 3 equals to 0, such that k equals to negative 3. So from there, we can now use whatever we had and solve out. Since we have located the value of k, two values of k, so we need to see which one will work. For there we say let log x, log to the base of 10 of x be equal to k. So we shall start with k equals to 1, and we shall find, to find the value of x is the same as taking 10 raised to 1 is equal to x, such that x is equal to 10. Our value of x is 10. And let's see for this case, if we say let log to the base of 10 of x be equal to negative 3, you shall find out that this one is going to be 10 raised to negative 3 is equal to x. And you will find this one is now working, so we shall have x is equal to negative, actually is 1 over 1000, or remains the same, which is 10 raised to negative 3. And you will find this is what you will have, or you may give it in decimal 0.001. Still the same. So, yeah, still the same. So, that's what we find as the values of x. Now we have found x will have two possible values. One is a fraction or a decimal, and another one is a numerator, which we just had as x equals to 10. We have seen that. So, I will do another one, and then the next one you will do it by yourself. Involving examples on this. I will work out, let me work out 5 raised to x, 5 into x plus minus 1. Okay, this is not under bracket, so in that way, is equal to 10. If you have an equation like this, let's expand the equation. We know if the factors are minus, then it means we are dividing. So we can say this one can be written as 5 raised to x, then 5 raised to x, but here it is minus, so it is divided by 5. That is what we are going to have. And this one will give us 10. So we can say let 5 raised to x be equal to t, because we don't know. So that we may have t into t over 5 is equal to 10. So this one we are going to have t squared is equal to, because t multiplied by t will get t squared, multiplied by t squared over 5 is equal to 10, such that t squared is equal to, multiply both sides by 5 to eliminate 5 on the denominator of t squared, so you will get t squared is 50. Such that if you find the value of t unknown, maybe positive or minus the square root of 50. So here we are going to get, it may be positive or minus the square root of 7.0711. So that is what we are going to have as the value of t. So meaning that if we say let 5 raised to x be t, then we shall come back and say now we have 5 raised to x is equal to t, and t we have as, let's consider when it is positive, so it will be 7.0711, and if that is the case, we are going to have 5 raised to x is equal to this. So we can't solve when it's that way. So what we do, we introduce logarithm on both sides, and if you introduce logarithm to base of 10, you are going to get, you will have something of this sort. So this one is 7.0711, and you will have this one can be written as x log to base of 10 of 5, which is equal to log of base of 10 of 7.0711. So if that is the case, you can find the value of x by dividing both sides by log to the base of 10 of 5, and even this side log the base of 10 of 5, such that you will find your x is equal to 1.2153. That's the value of x. And if we consider this 7.0711 as negative, we shall not find the answer, because you remember logarithm to base of 10 of a negative number will give you math error, so you will not find. So in this case, we shall just take one of it, of which is positive. We shall consider the positive part and say that our x here, which we have here, x here, is equal to 1.2153, and if you substitute, you should get what we have there. So this one is 1.2153, the same here. I will give you one use technique which you think is possible to evaluate 2 raised to x plus 1 is equal to 3 raised to x. Use any kind of technique to solve this one. As you can see, it is easy. That one is only consisting of 2 terms, which is 2x and multiplied by 2, and here is 3x. So you can use a simple technique and you solve that one and evaluate yourself how you can find it out. So from there, we can say we have come to the end of this further logarithm topic.